Okay, let's go with the examples. So you could pause the video and write out the example before I continue on. You have a farm with chickens and cows. The 81 animals have a total of 236 legs. How many chickens do you have? Now it might be tempting to say is the variable that we have number of legs on a chicken. But that wouldn't work because we know how many legs are on a chicken. There's 2 legs on a chicken. Not very exciting. You may also be tempted to just say chickens. But that doesn't actually answer the question, is it? Numbers of chickens, number of chicken legs, number of legs on a chicken. You have to be fairly specific when you write these variables. And one clue, as usual, is looking at the question. How many chickens do you have? Okay. So it's going to be number of chickens. And B, we need another variable, and probably a good one would be number of cows. So we have to come up with our 2 variables. So the first variable is going to be probably related to the 81. So 81 is the total number of animals. Total number of animals, we have chickens, we have cows. Total number of animals is going to be A plus B equals 81. So it's number of animals equals plus number of animals equals number of animals. And the second one, we're going to have to make an assumption here. We're going to assume that chickens have 2 legs and that cows have 4 legs, which, I would say is a fairly safe assumption. Is it always true? Of course not. But we're going to assume it is true. So now we need something legs. So this is going to be equal to the total number of legs. So if we had 7 chickens, it's kind of like the dollar bill one. If we had 7 chickens, we would have 7 times 2, 14 chicken legs. So the number of chicken legs is going to be 2 times the number of chickens. The number of chickens is A, so the number of chicken legs is 2A. Similarly, the number of cow legs, every cow has 4 legs. And there's B cows, so it's going to be like that. And those are the 2 variables with the 2 equations. You could solve these questions. I think I have set them up so they all have nice answers. But for now, we're going to move on. So again, you could pause the video and write out the question. Nope, we're going to start with 2 variables. Of course, I'm going to plow forward. We don't have to use A and B. I could use B and S. And so what I want to know is, how old is the brother? So definitely, and remember, the variable can't just be brother, because it could be height of the brother, weight of the brother, number of years older the brother is than the sister, many options. We're going to say B is the age of the brother right now. And S, I'm going to say, is the age of the sister. So we have 2 equations we have to come up with. So what we have is the sum of the ages is 19. So if we add up these ages, we get B plus S, the age of the brother plus the age of the sister, is 19. The brother is 4 years older than the sister. This is trickier than it looks. I'm going to kind of go to a side here. So we can have like brother equals so here's 4 possible options. So I'm going to call them 1, 2, 3, and 4. And what we have is, we know that the brother is 4 years older than the sister. So the question is, which one of these 4 is the correct answer? I'm actually going to give a little spoiler. It's actually 2. 2 of them are correct. So pause the video, try to figure out which one it is. So remember, the brother is older than the sister, right? So the brother is older than the sister. So is the brother equal to the sister's age plus 4? That sounds right. Is the brother equal to the sister's age minus 4? No, that's wrong. Remember, the brother is the sister, but 4 years older than that. Is the sister the brother's age, but 4 more than that? Nope. Is the sister the brother's age, but 4 less than that? Yes. So either of these equations would work, but these two would not work. So going back to this one over here, I will pick the first one. B plus S equals 19, and B equals brother is sister plus 4. And there we have two variables defined and 2 equations. And then we would solve and get the answer. That. Oh, here's a long one. I'll try to center it on the screen. Okay. So Joshua and Mackenzie are picking kumquats. It's a type of fruit. It's actually pretty hideous, but the name is cool. Joshua has paid $12 plus $3.50 for every kumquat he picks. Mackenzie has paid $67 plus 75 cents, I wrote it as 0.75, for every kumquat that she picks, which is pretty unfair, I think. How many picked kumquats will result in Mackenzie and Joshua being paid the same amount? This is a different type of question. So for this one over here, I'm going to do the variables over here. This is going to be more of like a y equals mx plus b thing. We're looking for where 2 equations meet. So it's how many picked kumquats will result in Joshua and Mackenzie being paid the same amount. So 2 variables in this case, so it's definitely this one. So K, we want to know how many kumquats. So it's going to be number of kumquats picked. Number of kumquats picked. And to equate, no, we need another variable, sorry. So the other variable would be, the thing that we don't know, is actually how much they're paid. So we'll say is the total pay. So K is the number of kumquats picked, K is the number of kumquats picked, and P is the total pay. And now we need our 2 equations. And what's going to do is we're going to do 1 equation for each individual here. So for Joshua, his total pay is, so he gets $12 plus $3.50 for every kumquat he picks. So he gets $12 plus $3.50 times the number of kumquats that he picks. And then for Mackenzie, the total pay, so she gets paid $67. So if I was her, I would show up and not do anything useful. But assuming she does work, $67 plus she gets 75 cents for every kumquat she picks. So she gets and we want to know when the pay is going to be the same. And this is actually also a linear system problem, because if I was going to just do a quick sketch of these graphs, so 12 plus 3.5k might look something like this. So this is Joshua's pay, and then Mackenzie's pay. She starts off at a higher amount, but she makes less per. And this is going to be the number of kumquats picked. This is the total pay. And when are they going to be paid the same? They're going to be paid the same over here. So over here, they've picked the same number of kumquats, and they're both paid the same amount. And so the intersection, the solution to the linear system is the intersection between these 2 pay scales, and that would be the answer. So those are our 2 variables, and those are the 2 equations.